This is titration question number 2 on page 484 in the textbook. So 1 gram sample of potassium carbonate is dissolved in 100 mils of water. A titration of this sample requires 24.20 mils of nitric acid to reach the end point. Calculate the amount concentration of the nitric acid. So the final thing we're being asked for is concentration of nitric acid. So we have potassium carbonate, we have 1 gram of it, and it's dissolved in 100 mils of water. And for nitric acid, we have 24.20 mils. So I'm just going to write out the information I have. So potassium carbonate, potassium's a 1+, carbonate is a 2-. So K2CO3 is the formula for potassium carbonate. I have a mass of 1 gram and a volume of 100 milliliters. Because we are working with concentration here as well, concentration is measured in moles per liter, so we want to convert any volumes to liters by dividing milliliters by 1,000. So I have 0.100 liters. For for nitric acid, so acid is with an H, H is H+, and nitric means with nitrate, which is an NO3-. So 1-to-1 ratio, so HNO3. And what I know there is volume is 24.20 milliliters. Once again, we're going to convert to liters by dividing by 1,000. So 0.0242 liters of nitric acid. And what I'm looking for in the end as my final answer is a concentration of nitric acid. So this is going to be my end point. Now, in order to calculate a concentration, I'm going to need to use number of moles divided by volume. And I have a volume but no moles, which means I need to figure out what my moles of nitric acid are. So I need that piece of information in order to solve my concentration. So I have potassium carbonate, which is going to react with nitric acid. And with carbonates, you don't need to know for this course the products. Typically, we talk about an acid and a base neutralization making a salt and water. So salt here is potassium nitrate. Both of them are charge of 1, so KNO3, and water. And with carbonates, we also make carbon dioxide. So you will be given all of the products in acid-base reactions if they involve something other than just a salt and water, so a double displacement reaction. So here I have 2 potassium, so I'm going to need 2 potassium nitrates. That gives me 2 nitrates, so I need 2 of my nitric acid. That gives me 2 hydrogen here, which end up in water. I need 1 oxygen there, which is going to come from carbonate. And then that leaves me with CO2, which is over here. So this is now balanced. So what my balanced equation tells me is that for every 1 mole of potassium carbonate, I need 2 times as many moles of nitric acid. So in order to figure out how many moles of nitric acid I need to figure out how many moles of potassium carbonate I have over here, and then double that. So for potassium carbonate, I know the mass and the volume. To get a number of moles with a volume, I would need a concentration, which I don't have. But I do have the mass, and the other calculation I could use for number of moles is mass divided by molar mass. And molar mass you get from the periodic table by looking up the atomic mass of each element. So the molar mass for potassium carbonate is 2 potassium, which is 39.10, 1 carbon at 12.01, and 3 oxygen at 16.00. And that gives us a total for potassium carbonate of 138.21 grams per mole. So now that I know my molar mass of potassium carbonate, I can solve how many moles are in 1 gram of potassium carbonate. So my grams will cancel and my final answer will be in moles. So 0.007235, and I'm going to round there to 4 moles. So 1 gram of potassium carbonate is 0.007234 moles of potassium carbonate. When I have a balanced equation here, I'm going to need twice as many moles of nitric acid. And in a titration reaction, the end point happens very shortly after the equivalence point, which is where I would be reaching my balanced equation. So my ratio of moles of each reactant based on the balanced equation, which means I need twice as many moles of nitric acid as of potassium carbonate. So I'm going to double that value, and that tells me my number of moles of nitric acid are 0.01444708. Now that I have my number of moles of nitric acid, I can use that with the volume in this equation to calculate the concentration. 0.01444708 moles per 0.02420 liters. And when I calculate that, I get 0.5979, so I'm going to round that to 8 mole per liter. And remember, capital M stands for mole per liter. So you can either write out MOL per L, or you can write out capital M.